So for this problem, we want to find how fast our angle is changing. So we need to find d theta. So we're going to write my angle, and this is what I'm trying to find. Okay, I know that the speed of the car, which I'm going to call x, is going to be 252 feet per second. So I'm going to use the feet per second instead of miles per hour because I'm given 100 feet. The angle is going to be 0.108, and this is a specific moment in time. So that's the only one that I'm not going to substitute because my angle is changing. The 100 doesn't change. This is going to remain constant. The car is changing, so x is changing. The distance is from the camera to the car is changing, and theta, my angle, is changing. So in order to do this, I need to use my tangent, because tangent is opposite over adjacent. And notice that I entered the 100 because that is a constant. X is not a constant, and theta is not a constant. It's just at this specific moment in time. So I'm going to go ahead and take the derivative. The derivative of tangent is secant theta. And remember, whenever you take the derivative, you have to multiply it by the angle or the variable, which is d theta. And then the derivative of 100x, I'm going to use 100x to the negative 1. It's going to be negative 1, 100x to the negative 2. And don't forget to multiply it by dx. So I'm going to solve for d theta. And 1 over secant theta is cosine, so I'm just going to go ahead and write it as cosine squared theta. Okay, so that's my answer. I just need to substitute everything I know. The only thing I do not know is x. I know what dx. dx is the speed of the car. I know the specific moment of theta that I want, 0.108, but I need to find the specific moment of x when theta is 0.108. So I'm going to go ahead and use tangent again. But this time I'm going to substitute the specific moment in time, which is 0.108, and solve for x at that specific moment in time. So x turns out to be 922.323. Remember to make sure that your calculator is in radians. So I'm going to substitute all my information. And I'm going to solve, and I get negative 0.02927 radians per second.